Myself, Dr. Shubhankar Samanta, Associate Professor of Jharkhand Raj College, wish to present my research work entitled Fast Mechanochemical Oxidative Lactonization Towards Bioactive Fluorescent Phthalate Analogues. Before discussing that, we have first what is the lactones. Lactone is the intramolecular cyclizations of the alcohol molecule with the carboxylic molecule, and this moiety has been prepared by the conventional method, and there are different type of the toxic chemicals, especially solvents are used. In industrial scales, a large amount of solvent has been discharged to that of the drainage water and indirectly affect to our food chain systems. So we want to synthesize these lactone molecules via green synthetic methods where higher atomic economy, lower effector and less hazardous chemicals has been used. There are different type of the sustainable technique has been used for the synthesis of the lactone derivative, such as microwave technique, photochemical technique and electrochemical technique. Now we use to synthesize the lactone molecules by mechanochemical grinding technique. Here the mortar pestles has been used for the synthesis of the lactone molecules by simple grinding, and there are different type of the cascade reaction has been happened in the grinding method. This is the first mechanochemical method for the synthesis of lactone derivatives. This is the dihydronaphthyl and it contains the aldehyde and the acrylate functionality, and this aldehyde functionality has been oxidized to give the lactone derivatives, and these lactone molecules is similar to that of the bioactive molecules tiliphosphoride and thionosin C and justidine B, and these are the bioactive molecules similar to that of the anti-cancer drug, antioxidant and anti-inflammatory. And before discussing the lactonization, we have first optimized the reaction conditions using the different type of the oxidizing agent in the presence of sodium chloride and tertiary butyl hydrogen peroxides. In the presence of the aid equivalent of the sodium tertiary butyl hydrogen peroxide, with the increasing the additions of the sodium chloride, we get that of the 2A along with the 3A. The proportion of the 3A increases with increasing the addition of the sodium chloride. And this had been confirmed by the NMR study. In the NMR study, it has been shown that with increasing the additions of the sodium chloride, we get the 3A amount exclusively over the 2A by the additions of the up to 8 equivalent of the sodium chloride. And we have generalize the reaction condition in the presence of the liquid assisted grinding conditions. In the liquid assisted grinding condition, with the presence of the 1.4 equivalent of sodium chloride in tertiary butyl hydrogen peroxide, we get the mixtures of the dihydronaphthyl lactone with that of the naphthyl lactones, and this has been proposed by the following mechanisms, where the CHO group has been oxidized to give the carboxylic acid, which undergoes lactonizations and followed by the formations of the exocyclic double bond and the two times of the 1,5 hydrogen shift, we get the naphthyl lactone, and these 5 steps has been happened in the mortar pestle in one step. And we exclusively get the single isomers of the naphthyl lactones here in the presence of the sodium chloride tertiary butyl hydrogen peroxide with 1 hour stirring under neat condition, where 8 equivalent of sodium chloride has been used along with that of the 8 equivalent of tertiary butyl hydrogen peroxide. In each case, we get the exclusive amount of the naphthyl lactone with moderate to good yield, and one of the structure has been confirmed by that of the CCDC numbers, and this has been given in the slide. And we have compared the effector of the reported protocols with our protocols, and in our protocols has lower effector, means less hazardous chemicals has been eliminated in the environment compared to that of the photochemical and electrochemical methods, and this effector has been calculated by this following formula, which has been reported in the previous literature. And during the reactions, we get that of the serendipitous observations. Here, with lowering the temperature from that of the room temperature to 0 degree centigrade, we get the saturated analogues of the cyclopentanone derivatives. And here, the ionic pathway mechanism has been proposed, where the 1,4 additions of the alpha beta unsaturated ester followed by the intramolecular addition to the formyl group, we get the cyclopentanol intermediate, and this cyclopentanol intermediate, upon eliminations of the oxygen molecules, we get the saturated analogues of the cyclopentanone. And we get also the bicyclic phthalate analog using the intramolecular lactonization techniques, but here the motor pressure technique has been avoided, where in the motor pressure technique we get only the carboxylic acid derivative, and this limitation has been overcome in the presence of the palladium acetate under neat condition at 110 degrees centigrade, and we get the secundrite E analogues. And the proposed mechanism for the formations of these secundrite E analogues has been proposed. Here the palladium 2 first coordinated to that of the alkene and undergoes intramolecular oxidation followed by that of the elimination of the palladium 0, and this palladium 0 has been oxidized to palladium 2 in the presence of air, where the catalytic cycle has been maintained, and it would got that of the secundrite E with moderate to good yield. We have also observed the photophysical properties of our synthetic molecules of the different type of derivatives, and we get that 3G and 3H had higher emission properties. This is due to that of the homolog interaction of the electron donating group of the methoxy with that of the electron withdrawing carbonyl group, and this solvatochemic effect shows that the methanol and the water get the two peaks, and the two distinct peaks has been explained by the excited state intramolecular proton transfer phenomena, where the keto and enol form has been present, and the enol form has higher bathochromic shift compared to that of the keto form, and this has been confirmed by the density functional theory. Again, the calibrating curve has been obtained using the different type of the percentage of water, and from this calibration curve we can easily get the unknown percentage of waters in any samples. In conclusion, we have developed a general methodology for the preparation of the naphthyl lactones along with that of the dihydronaphthyl lactones under mechanochemical and neat condition. And the low loadings of that of the sodium chloride, we get the inseparable mixtures of the dihydronaphthyl lactones with the naphthyl lactone, but high loading of sodium chloride, we get only exclusively the naphthyl lactone, which has fluorescence property, and it has been used for the water sensor. And a serendipitous observation was also obtained for the formation of the saturated cyclopentanone, and the methodology has been outcome for that of the formations of the bicyclic phthalate analog in the presence of the palladium catalyst. In conclusion, I would like to thank Dr. Devnaran Roy, Principal of J.Raj College, and my collaborator Professor Devbrata Maiti, and special thanks to IIT Mandi ANRF+IIT. Thanks for watching this video.